A polynomial function is a function that can be expressed as the sum of finitely many terms of the form a times x to the n, where n is a non-negative integer. So I'd like to look at some examples and non-examples and some terminology related to polynomials. First, for some non-examples, because the exponents need to be non-negative integers, radical signs like square roots and cube roots are going to be a problem because they relate to fractional exponents. In a similar way, if we have a variable in the denominator like 1 over x, that relates to negative exponents. And so these are examples that aren't polynomials. An example of something that is a polynomial function would include a linear function like 3x plus 10, or a quadratic function like x squared minus 5x plus 8, or a function that maybe has a higher exponent, so we could have 5x to the 10 minus 3x to the 9 plus 4x. And for all of these examples, we're simply raising a variable to a non-negative integer exponent, which means if I plug a number into the variable, I'm basically just multiplying it with itself a bunch of times and adding it to itself, or adding it to some other numbers. And so we can do that for any possible x value. So the domain of a polynomial function is always going to be all real numbers. And so that's why polynomial functions are very nice functions to work with. So there's some terminology that I should mention related to polynomial functions. The number that's multiplied with the variable is called the coefficient, and the exponent is called the degree. So for each term, we can identify a coefficient of the term and a degree of the term. The highest degree is called also the degree of the polynomial, and the highest degree term is called the leading term. And finally, the coefficient of the leading term, shockingly, is called the leading coefficient. So let's take a moment to look at a quick example. So here I have a polynomial with 4 terms. There's a degree 3 term, a degree 2 term, a degree 7 term, and the last term, it's called a constant term. I could think of it as degree 0 because x to the 0 power is always equal to 1, and so negative 5 times x to the 0 power is simply just equal to negative 5. Well, looking at the 4 terms, we see that 7 is the largest exponent. So 2x to the 7 is the leading term. Even though it's not listed first, it's the leading term. We usually write that highest degree term first, but we don't have to. So with that in mind, 2x to the 7 is our leading term, which means that 2 is the leading coefficient, and 7 is the degree of the polynomial. In a separate video, I'll describe how recognizing the degree of the polynomial and the leading coefficient of the polynomial can help us identify information and characteristics about the graph of the polynomial function.